Hello, this is Scott. Welcome back again to my YouTube channel. Today we're talking about automatic document classification, and this is a continuation. This is part 2. Hope you were with me last time where we talked about the ability to classify documents automatically, and we went through a process where we used Statistica to comb through 5,000 documents and come up with a frequency list for different word stems. And if you weren't able to join, you can search for this S40. This is the part 1 video. And in that, if you will go to Statistica, you will see at the end of that video that we created a document that looks like this, which is essentially, we have all the 5,000 different documents. We have a topics earning, which is the document actually an earning document. In other words, the actual, it was an earnings document, report, etc. And we looked at the documents as well. I think I still have it up. So this is what the documents look like. This comes from a Reuters database. I mentioned a book that you can find this in. So there you go. And then the goal here, obviously, is it takes a human being a long time to read through this document, determine whether this document is an earnings report or not, and then they go on to the next document. And we can literally use Statistica and within or other machine learning, and we can do this, very rapidly across thousands of documents. So again, last time was about taking the unstructured data and creating these frequencies. And this time what we're going to do is we are going to use the information collected and come up with just a very rudimentary machine learning classification. So probably the thing to do now would be to, let's just close this analysis and let's do this in a workflow. I could do this all menu driven, by the way, but just so that we can see our process flow, let me just create a blank document. And I'm gonna, since I have this data open, I'm just gonna put this Reuters data. So this is the data itself. And then I'm gonna do some feature selection. Feature selection allows me to determine what variables are most important to a model. And so if I go up to the data mining tab and under the tools group and do feature selection right here and connect these two, then I can point Statistica at the columns needed. So just to let you know, I'm not going to use the file name. This will be our target. We're going to try to classify this variable right here, yes or no. We're going to use this for cross-validation, and then we're going to use the predictors here as well. So let me double click on feature selection. Let me do that. And then so the categorical dependent, whether this is earnings or not, and then the predictors essentially is this entire set. I can scroll down and hit the shift, and I get 354 predictors or so, and continue on with that. Some of the other things that I could do is I could do some plots. Let me see. Let me increase. This will allow me to take the results downstream. So when I build a model, I won't be building across, 350 something variables, most of which really don't contribute that much. So, but let's say take the top 20, well, for demonstration, let me just take the top 15. You can make this whatever you want. You just want to make sure that you're taking the variables with the highest value. You might even want to look at those before you make that determination. As our goal here is to really do something quite simple, and that's just to look at a tree, simple tree. This is not a full machine learning model building process. I've got other videos that show you comparison of models, picking the champion model, deploying that out and everything. So this is not about that. This is just about illustration of using our structured text data now. We started with unstructured data. Now we're using that structured data, and can we come up with a model to do that? All right. So I think we're ready. Let's just go ahead and run this, see what we get. I've got a couple of different outputs. I've got the chi-square statistic. The larger chi-square, the more predictive this is. We can see versus, VS, cents, shares. These are all stems. Again, I explained this last time. If you need to review, net obviously is net earnings or net profit, etc. Is important instead. So these are important to determine whether the document is earnings or not earnings. And if I want to look at that in a plot, I can see that we start to tail off here, and these last values contribute about the same. And if we were to see that, it just add more terms, it would just continue to tail off. So for illustration's sake, we'll keep this pretty simple and do that. We will create a downstream document. So feature input descriptor, if I run that, what that creates is this little downstream document right here, which instead of 300 and something, whoops. I want to get the top. Get the top predictors here. Okay. So let me see. Let me select the feature selected input subset. So the subset of the 300 something predictors. And again, we're just selecting the top 15 here. So let me run that. Okay, so we now have our target, and we have the top 15 predictors, 16 columns in total. And now we can run a predictive machine learning model. So in the data mining tab up here, let's pick a CHAID classification model, and we can, let's see, let's pick exhaustive classification CHAID. It'll take a little longer to run. But if I double click on this and I go through, I'm going to go ahead and select vCross validation and click OK. You know, okay. All right, so I'm actually not going to pick this one. So I picked this out of this CHAID menu. Actually, I want to go to iTrees. I want to pick a different one that has more richer output, especially for a educational section, illustrative purposes. So let me pick this. I do want a CHAID. So advanced classification CHAID. I'll drop this down and connect this. All right. So the point being is, in a real, if I was fully model, I'd probably pick a lot of different algorithms and pick the best one. Here, we just want to illustrate. I just want to show you the results of a tree, show you what it looks like. So let me do that. So on classification, we're going to use equal. We're going to use pretty much all of the defaults. The one thing that we'll do is we'll use vfold cross-validation, and that's going to allow me to actually generate a better model. It'll take a little longer, but it's going to run pretty quick here with only 5,000 rows. And let's see if there's anything. What else do I want? I can generate code. I can generate predicted values. And running this will generate a downstream document for us with the predicted values, and then it'll produce the tree that I want to review as well. So let's look at the tree real quick. And I know this is going to be small for you. Let me see if I can zoom in a little bit with a magnifier. So if I zoom in at the top of this tree, let's just see what's up here at the very top. So it actually picked verses to split first, and then it picked cents on the dollar, CTS, and then said, etc. So we could look at the tree there. Then we can also look at the predictions themselves. And I've said that the tree, I mean, there's a lot of different output. We can look at the terminal nodes. We can look at importance. And these are just the defaults. And I could have added more. Actually, there is one thing, if you'll allow me, one thing that's kind of nice is if we look at the confusion matrix. I'm not going to pick the cost because I'm not going to put cost in here, but the predicted versus the observed, and I want to pick the get a plot. So running that, and then the output, and I get this one kind of nice plot. This is a visual confusion or classification matrix, and I can see here. I can kind of spin this, and my correct classifications are this tall bar here where I predicted no and it was no, and this bar back in the corner I predicted yes and it was yes, and then I've actually misclassified in these two off diagonals. And if I want to look at the actual frequency there, I can see that generated. So I have, 38 to 3,900 correct no's, a little over 800 yeses, and then you can see the number of times that I misclassified. And you can certainly use, again, back to our business goal is to determine whether something is an earnings report or not. And this is simple classification, so I can look at each one of these documents. I also can see the probability for which, I'm predicting. So this is a 98% probability. I predicted no, and in fact, it was no. This is 98, and I predicted no, and then it was no. Here is an example of a misclassification right here, where I predicted no, and in fact it was a yes. So not perfect, and probably with a simple model like this, you saw how fast I did that. We probably want someone to review the results, but certainly they could do that much quicker with the aid of an automatic document classification system than on their own. So that was the end goal, is to improve the document classification. So that's an example of text analytics, and I've got some other ones in the pipe that are coming down, and I'll share with you soon. Thanks for joining.